Today we are going to discuss about the calorific value of fuels, and in the last class also we defined the calorific value of fuel. In short we say CV, calorific value. How much heat is produced by burning 1 kg or 1 unit volume of fuel. So we can also define a calorific value like this. It is the energy liberated, that means energy produced by the complete combustion of unit mass or volume of a fuel. Now you can tell me what will be the unit of calorific value. So definitely unit of heat is kilocalorie or kilojoule. So if we consider kilojoule in SI unit, then the unit of calorific value will be kilojoule per kg. Per kg for what? Per kg of fuel, if it is solid or liquid fuel. But if the fuel is gaseous, the unit will be kilojoule per meter cube or per centimeter cube. So the calorific value is expressed in kilojoule per kg for solid and liquid fuels, and for gaseous fuel it will be same kilojoule, but in place of kg we will consider the volume. It may be in meter cube. Okay, what are the units? Kilojoule per kg or kilojoule per meter cube. A fuel is a compound of basic component is carbon. Okay, but along with the carbon, hydrogen is also present in the fuels. We call the hydrocarbons. But if the fuel contains hydrogen, then what will happen due to the chemical reaction? Hydrogen will react with the oxygen during the combustion, and it will form water. And you should remember, the water will definitely be evaporated because there is enough heat to evaporate the water. So it will still water, but we will call it a vapor state of water. Okay, the hydrogen present in the carbon will be converted to water due to the chemical reaction. From hydrogen we get water, and this water will absorb the heat to become steam. Steam means vapor. That means during the combustion the heat is absorbed by this evaporation also. Out of the total heat produced by the combustion, a part of the heat is absorbed during the evaporation of the water. And if we imagine the opposite process, during evaporation heat is absorbed. Now if we do the process in the reverse order, that means from steam or from vapor to the liquid, then what will be done? Then it will release heat. During evaporation it will absorb heat, but if it is condensed, then heat will be released. And that is said in this statement: if this water, that means water vapor, is condensed, a large amount of heat will be released. Otherwise this heat is utilized for vaporization, not for the actual purpose. We burn a fuel to get the heat, and out of that heat a part is used for evaporation of water, which is formed within the chemical reaction. Water is formed and that water will be evaporated. But if we can reverse the process, decrease the temperature, then that heat can be liberated, released, and that is also part of that heat is produced by burning carbon, actually by burning the fuel, not only carbon. So we can see the reactions. Say, since it is a compound of carbon and hydrogen, we first consider the carbon component. Carbon, when combined with the oxygen, will form the carbon dioxide. This chemical reaction is a balanced chemical reaction. Okay, number of molecules atoms are balanced in both the sides, left side and the right side. Now the atomic weight of carbon is how much? Is it so? 12. So this is 16 is 32, and here it will be 12 plus 32. How much? 44. Now if we consider it to be in kg, that means 12 kg of carbon need 32 kg of oxygen, and that will produce 44 kg of carbon dioxide. Now make it 1 kg of carbon, then oxygen will be how much? 8 by 3. 32 by 12 means 8 by 3, and that will produce 11 by 3. What do you mean? 1 kg of carbon needs 8 by 3 kg of oxygen, and that will give 11 by 3 kg of carbon dioxide. Okay, in terms of mass we are considering in this case. So that is important that you should understand. So for 1 kg of carbon, how much oxygen is required? This much of oxygen, kg. So in the air, what is the amount of oxygen present?
21%.
21% in what? It is in volume or weight? Mass. 21% is by volume, but approximately 23% by weight or mass. Okay, in the atmosphere. So accordingly, that much air will be required. That means more air will be required, because air contains only 23% of oxygen by mass, and by volume it is 21%. Okay, fine. Now consider the hydrogen. We have already said that the fuel contains hydrogen, and this hydrogen will combine with the oxygen to produce the water molecule. So this is again a balanced chemical reaction. 2 molecules of hydrogen combine with 1 molecule of oxygen to produce 2 molecules of water. And the chemical reaction we can say, how does it, we can say, is 4. Oxygen is again 32, and water how much it will be? It will be 36, because 16 plus 2 is 18, 18 into 2 is 36. Okay, that means if we make it 1, then it will be 8, and it will give how much? 9. That means 1 kg of hydrogen needs 8 kg of oxygen, and that reaction will produce 9 kg of water. Water may be liquid, water may be vapor. Although it become vapor, the weight will be same, mass will not change. So these reactions are important to understand the calorific value, for calculation of calorific value also. So there are many chemical reactions to be considered for calculating calorific value of fuels, but from our subject point of view, we need not go to the details of all this. Simply we have to remember some formula to calculate the calorific value of fuels. So these are some important points. What are the things? The calorific value of a fuel can be determined. There are 2 main methods of determining calorific value, and one is by calculation when the composition of fuel by mass is known. That means, what is the composition? What does a fuel contain? Can you tell me? A fuel contains what? Generally, we know it contains carbon, it contains hydrogen, sometimes it contains sulfur also. So all this will be combined with the oxygen, and accordingly they will produce the oxides of the respective things. Carbon will become carbon dioxide, hydrogen will become water, sulfur will become sulfur dioxide. So if we know the exact composition of the fuel, say 1 kg of fuel may contain say 800 grams of carbon, say 100 grams of hydrogen and 100 grams of sulfur. So this is called the composition, percentage composition of the fuel. Another method, so from this we can calculate the calorific value. How? Carbon will produce how much heat, hydrogen will produce how much heat, and sulfur will produce how much heat. All this will be added and that will give us the total calorific value. We can also do experiment. Exactly, we can burn some fuel, take some fuel, it may be coal, it may be any liquid fuel, petrol, diesel or anything, burn that fuel and entrap that heat in a container. Keep the heat within a container with some insulating materials and measure the increase in temperature. From that increase in temperature, we can measure the heat, because what? Q is equal to how much? It is either mCp dt or what? mCv dt. So if our instrument is at constant pressure, then we will consider this first formula. If volume constant, then we will consider the second formula. Accordingly, by using some experimental method, we can measure the calorific value of some fuel. Okay. There are two heating values. So what is heating value? Heating value means calorific value. Same thing. Heating value or calorific value is same. So what are those heating values? One is higher or gross heating value, higher calorific value or higher gross heating value, that is called HCV, higher calorific value, or we can say gross calorific value. This is the most common term we generally use, higher calorific value. Okay, what is higher calorific value? Let us define higher calorific value. Definitely, if we burn a fuel, it will produce some heat. Now, if the products of combustion are cooled to the room temperature, after burning, temperature will increase, and that is why the water produced will become vapor. Now, if we decrease the temperature to the room temperature again, then what will happen? That vapor will become water, but that will release the heat. So what will happen? The water vapor will condense, evolving its latent heat of vaporization, producing the maximum amount of heat per kg of fuel. And this type of calorific value is called higher calorific value. That means this gives us higher values, heating values of the fuel. How it is done? This is like, say, you have some income, but along with the income, you have some expenditure. Now, if you do not consider the expenditure, then you will get that your income is high, because you are not considering the expenditure component of the income. For every income, for any business, income involves expenditure. So if we do not consider this expenditure, that means if we deduct the expenditure, then we will get higher value of higher calorific value. Similarly, when we burn the fuel, we get some heat, but that heat also includes, that heat is total heat minus the water component. Water is converted to vapor, that heat is not considered. That is why it is called higher calorific value or gross. In case of income, we call it gross income. What is gross income? Without considering the expenditure part, that is called gross income. But if we deduct the expenditure, that income is called net income after deducting the expenditure. And that, in case of a calorific value, that is called lower or net calorific value. In short, it is called LCV, lower calorific value. Now, what is this lower calorific value? It is simple. assuming that the water vapor formed during combustion leaves as vapor. So the vapor is not again converted to liquid. We consider that that is the part of the system, so let them go. Whatever is utilized by the system. And therefore, what is the LCV, lower calorific value, is higher calorific value, that means gross income, minus heat carried away by the water vapor formed per kg of fuel burned. So this water vapor, that means liquid water, will absorb some heat and it will become water vapor. So this heat is deducted. This is like expenditure, and that is why the lower calorific value is less. This is like net income. So higher calorific value minus the heat carried away. How much heat is carried away? What is HFG? You already know what is HFG. The latent heat of vaporization. Okay, latent heat of vaporization. So what is formed? And immediately water become vapor by absorbing the heat from the combustion process, and that is a loss actually. This is loss or expenditure. So what is MW? The mass of water produced by burning. Produced by what? H2 plus O2 to H2O. This water, whatever water is produced during the combustion, that mass of water multiplied by latent heat of vaporization of the water. So I think it is clear for you, because during combustion water is produced and that water become vapor, and a water to become vapor, it must absorb the latent heat of vaporization, and that latent heat of vaporization is used by the combustion heat. Whatever heat is produced from the combustion, from that heat is utilized. Okay. Higher or gross calorific value, you have to remember this formula to calculate the higher calorific value or gross heating value. You need not put anything, then you simply write 350 C divided by 100 hole 1430 H minus O by 8. O means oxygen, plus 91.6 S. Now C is, what is C? H, O and S. This is the percentage of carbon, hydrogen, oxygen and sulfur present in the fuel. Okay, what is C? That means the composition of the fuel. That means 1 kg of fuel. If we consider say 100 kg of fuel, in that C percentage is what? C percentage is carbon, H percentage is hydrogen, O percent is oxygen present in it, and S percent is sulfur. And those value will be given. You simply have to put the values. Percentage of say a particular fuel, any fuel contains say 62% carbon, 12% just a arbitrary value, hydrogen 8%, oxygen, and rest is sulfur. Now come to the lower calorific value. So simply lower calorific value is higher calorific value minus something, and that something is what? Minus this much. 9 by 100. This is same 100 like the HAV divided by 100. To calculate the higher calorific value and lower calorific value, in which this composition will be given, and you have to put the values of carbon, hydrogen and oxygen, and accordingly you calculate the HCV and LCV, lower and higher calorific values. Now, I have already mentioned that calorific value can also be determined by some experimental method, and one of that method is Bohm calorimeter. So what is a calorimeter? Then thermometer measures the temperature, okay? Calorimeter measures the heat in this apparatus, Bohm apparatus. So by this apparatus we can measure the calorific value of fuel. You can look at the diagram. So what is inside this container? So this container is insulated container. What is insulation? You know, heat cannot go out of the system, heat cannot enter into the system. Okay, insulating material is there. Then inside the insulated container there are some water, and the temperature of water can be measured by this thermometer. You see, this is a sealed bomb. So this is like bomb. The actual burning will take place over here, that is why it is called bomb. And this is a sealed bomb, and the material is very good conductor. The sealed bomb, the sealing material is good conductor. That means whatever heat is produced due to by burning the fuel will go to the water easily. Also, this sealed bomb should contain some oxygen, because to burn something inside a container we need oxygen. So we have to supply sufficient oxygen. So in this case the oxygen is not supplied continuously. Already some oxygen is kept inside that container. Now there is a sample cup. So this is sample cup. Now here we can put the fuel. So this is the fuel. So this fuel is kept in a cup. If it is a liquid fuel, then also it is okay. In a cup we can keep some liquid, petrol, diesel or anything, liquid or solid fuel. This experiment is not for gaseous fuel. Now we are to burn, we keep some fuel in this cup. Now we are to burn this fuel. How we can burn? So for that a special arrangement is there, that is called the ignition wires. By using some electrical spark or so we can burn the fuel, start burning. To burn anything we need to ignite the thing. To burn the LPG you use one lighter. To burn the fuel inside this cylinder we use, inside an petrol engine we use one spark plug. This way, to burn the fuel we have to use some ignition system, and this ignition where with the help of high voltage current we can burn the fuel. Now just imagine, if we burn the fuel, oxygen is already over there, then this fuel will burn. If we ignite it, it will burn, and while burning it will produce heat, and this heat will dissipate to the water, because these are good, very good conductor of heat. Heat will dissipate to the water. Now to distribute the heat properly, evenly, we use one stirrer, just stirring mechanism, okay? Like our mixer grinder, that type of thing, we'll rotate this stirrer, and that way the heat will be uniformly distributed to all the water, and that temperature will be recorded by the thermometer. So what we get? We get initial temperature T1 before combustion and the final temperature T2 after combustion. So this will give us the DT. Now just imagine, in this case, what is the process? Heat addition process is constant volume process or constant pressure process? Someone tell me?
The constant volume.
Constant volume, very good. So definitely we can say mCV dt. From that we can calculate the Q. And if we calculate the amount of heat divided by mass, then what is this? Kilojoule per kg. And this is the calorific value of the fuel. So this bomb calorimeter is important from examination point of view. You may have to explain the working of a bomb calorimeter, how it works, how the calorific value can be measured by using a bomb calorimeter. Suitable only for what? Solid and liquid fuels. So if you have any question,